Section 6.1, Polynomial Functions and Polynomial Inequalities. We are going to cover zeros of polynomial functions and zeros of polynomial equation, graphing polynomial functions, and solving polynomial inequalities. Let's get started with the zeros of polynomial functions and solution of polynomial equations. The number C may be a complex number is a zero of the polynomial function px if the p at c equals 0. That is also expressed by saying that c is the root of the polynomial function px, and c is a solution of the polynomial equation px equals 0. So the difference between the function and equation is the function is the expression by itself, like p of x, and the equation is when the expression equals 0, or you have the equal sign and have the left expression and the right expression. So this one is the function, and this one is the equation. You can notice the equal sign as part of the expression. So a polynomial equation in one variable, we say that the variable x is an equation that can be written in the form of an x to the power n plus an minus 1 x to the n minus 1 plus and so on until the latest term, like the a1x plus a0 equals 0. When you see the equal sign, so that means this is the equation, and to be called the polynomial equation, when the n, which is the non-negative integer, and the an minus 1 down to a1 is 0, they are constant terms. That an not equal to 0, we say that this equation is of degree n and call an the leading coefficient. Let's take a look at the examples. Do the given values of x solve the corresponding polynomial equations? It's in the form of the px equals 0. That means we verify that the given values solve the corresponding polynomial equations. When verify as 0, there is no need to rewrite the equation in the form of the definition. So to verify, we just replace the value of the x with the given number and then see if it turns out to be the true statement. In part A, x equals 2, replace x with the 2. We have 11 times 2 squared minus 12 times 2 for the left expression. And for the right expression, we have 5 times 2 to the third minus 20. And then simplify further, 11 multiplied by 4 minus 12 times 2, that's 24. So we have 44 minus 24, that is 20 as the quantity on the left-hand side. For the right-hand side, 5 times 2 to the third is 8. 8 times 5 is 40. 40 minus 20, it turns out to be 20. So we have the left equals the right quantity. That means we have the true statement. So we can say that x equals 2 is 0 of the polynomial equation 11x squared minus 12x equals 5, x to the third minus 20. Let's move on to part B, where x equals negative 8 and the polynomial equation is 2x to the third plus 13x squared minus 22x plus 21 equals 0. Replace x with the value negative 8. We have 2 times negative 8 to the power 3 plus 13 times negative 8 to the second power minus 22 times negative 8 plus 21. And then simplify more, negative 8 to the third power, that is negative 512, plus 13 times negative 8 squared, that is 64. 22 times 8, and that is 176 with a positive sign because negative times negative become positive, and then plus 21. 2 times negative 512, that is negative 1024. 13 times 64 is 832. plus 176 plus 21. Put in a calculator real quick. It turns out to be the value 5 on the left-hand side. So that means it's not the same as the number 0, which is the value on the right-hand side of the equation. Therefore, we can say that x equals negative 8 is not 0 of the polynomial function 2x to the third plus 13x squared minus 22x plus 21 equals 0. Now let's look at one more example where x equals 2 plus 6i, which is a complex number, and the polynomial equation is x squared minus 4x plus 40 equals 0. X is 2 plus 6i, quantity squared for the first term, minus 4 times 2 plus 6i for the second term, and then plus 40. And we're going to simplify as what we did in part A and part B to see if the number comes out to be 0, the same as the right-hand side or not. Recall the I is the imaginary number, which is negative, square root of negative 1. So I squared is negative 1. For the quantity power 2, it means the quantity times itself twice. 2 plus 6i times 2 plus 6i. And then minus 4 times 2 and 4 times 6i with a negative sign. So we have negative 8 minus 24i plus 40. And use the FOIL technique to expand the first product there. 2 times 2 is 4. 6i times 2, that's 12i, another 12i. And 6i times 6i, that's 36i squared. Simplify negative 8 and 40 become positive 32 minus 24i. The I squared is negative 1. And then we simplify further for the number 4 and 32. That's it becomes 36. 12i, and negative 24i, they're gone. 36 times negative 1, that is negative 36, turns out to be 0. So we can say that x equals 2 plus 6i is 0 of the polynomial equation x squared minus 4x plus 40 equals 0.